Hello everybody, guys and girls, YouTubers out there. I've had about 10 requests in the last week or 10 days to fix CTEK battery chargers, which I'm not doing, but as chances would have it, a chap down the road, literally down the road, said, "Oh, where are you?" I said, "Well, this is where I am." He says, "Oh, I'm just down the road. Will you do my battery charger?" In the interest of the local community, I said I'd have a quick look, and I came back to my office and it was hanging on the door in a plastic bag. It's a CTEK battery charger. So a quick look inside, and I wouldn't have bothered filming this, although this has failed in a slightly unusual way, so I thought you might find it interesting. So I bashed the lid off, put it in a vise, hammer along with a chisel, and then you can open them quite well without doing too much damage. Look, and it's made in Sweden by CTEK. 2 amp fuse it says, although I noticed it's got a 13 amp UK fuse in the UK plug in there, which is not good. But it's blown up. It's not working. It's dead. It's definitely dead. Definitely dead. Now I've noticed there's a bit of an innovation on this one. Look, you see this thing here, that thing just there. Never noticed that before. This must be an upgraded version of the CTEK MXS5. That little thing, I think they've done as close as they can to what Noco have done and stuck a thermistor in the bung, but this thing gets very hot, but it would have to cool right down and just be running really on idle in a cold environment. I suppose you could get some idea of the temperature compensation, although it's not claimed anywhere on the spec as a temperature compensated battery charger. As you know, if you leave a float charger on a battery without temperature compensation, then you're asking for trouble basically. Or is that an LED? What is that that's poked in that hole? That looks like an LED to me. But why would you need an LED? It must be, no, it's a thermistor, I think. It is a solid black, not solid, not translucent, but opaque epoxy blob. So it's a thermistor. Now before they were kind of strapped across there and stuck on the heatsink to prevent the internal overheating. So maybe they've repurposed that to do something to do with the ambient. I'm not sure. But anyway, it's a slightly different revision, so I thought it's worth having a quick look at it. So from the top it looks very similar. You've got the 2 heat sinks and the transformer and everything else inside. But it's not working, there's nothing coming out of it. So let's just pull this out of the bung. Let's unbung it. Pull this bungy thing out of the end. There we are. And then withdraw the electronics. Oh, well, straight away you can see, can't you? I'll turn it around that way. You can see a little bit better. There's been an event somewhere. Moisture has got in, I think. It says IP65. It isn't IP65. It leaks like a sieve. We proved that in the last video. So it shouldn't have that stamped on there. Oh, look. A big black magic smoke stain on the inside of the enclosure. Just there. It's more of rather than the smoke vaporization, that's from an arc. It doesn't come off. The sooty smoky ones will just rub off on your finger and make it black. But that's quite well imprinted into the plastic. So what's been going on here? So if I turn that over that way, yeah, so it's this area here, denoted by something that's been going on. So just quickly point these things out. You're probably getting bored of this by now. We've got input live, the fuse, filter capacitor, 2.22 microfarad, 400 volt X2 class capacitor. Is there a varistor in there at all? Look, they haven't even bothered to cut the wires off. Look, they've just bent them over to save money. They're just forever on a quest to try and reduce the price of these things to the point where it gets self-defeating. A couple of discharge resistors to make sure you don't get a shock of that capacitor if you whip the plug out at peak mains input. Common mode rejection choke, that's that thing down there. stop the switching noise going back down the power lines and radiating out and interfering with your kit. Another capacitor there. Yeah, another one of those X2 capacitors, C38. And 4 rectifier diodes going around here, V plus output to a large Samsung capacitor. We know about those. If you want to find out just how good they are or not, don't rely on me, look on the web. Pages of people moaning about them. And an event around here somewhere. That's the snubber diode, which often blows. Well, that's my meter beeping at me. Current sensing resistor, all the power through the primary of the transformer goes through the FET, through that resistor to AC 0 volts, and the voltage generator across there going down that track there to this chip manages the overcurrent situation, so that if on a switching cycle, if the voltage generated there is too high, it goes down there, tells the chip, hey, we've got an overcurrent situation, switch me off before you blow me up. And that's what it does. And you can see there's some kind of arcing or leakage has been happening across there. That's a very close together, because there's 360 volt spikes on here on the source of the FET, and on there, and then it goes through this resistor to 0 volts. So there's between these two tracks is 360. Now what they haven't done is what I would normally do, is to make these pads oval. If you overlies these pads and reduce the land at the sides, then you can increase that gap significantly. And then we looked in the other chargers and power supplies we saw, and it's very common practice to route out a slot in there to stop this surface leakage tracking problem. So we had a bit of a blow over there. There's some stuff. I can't immediately see where all the dirt has come from. Can you? So let's have a closer look underneath the magnifier. And there you can see it in its full glory. Nothing appears to be completely destroyed. I think they've taken the ident off the chip, as if we can't guess what that is. And yeah, a lot of detritus across this point there. So something had been arcing on here and subliming onto the inside of the case, but it's not entirely clear what. It is dirty, look. I think this has been caused by moisture ingress, actually. 4.7k resistor, 47.47 ohm, 47k capacitor, and the snubber diode there. Remember, we had a problem with the last one with these snubber diodes going short circuit. They're fast, Schottky 1000 volt, 4 to 5 nanosecond recovery diodes. They go short circuit because they put cheap ones in. The power FET, management circuit, and then a bunch of transistors and other things to do the management of the power supply. And of course there's the opto coupler to feed back the demand from the low voltage side. Look at that. Obviously an iron pin has gone very rusty there. Some kind of detritus on there. I think at some point hold on. Yeah, sorry about that, it was the phone. And yeah, so we've got some rust here. Look, there's some kind of metal pin there that's rusted. Mega 88, that's an 8-bit AVR Atmel chip, now supplied by Microchip actually. It's got all sorts of wonderful things on it, not very accurate. I think it's got a 10-bit A to D, so the accuracy of the voltages it can measure is in 10 bits, which is detailed in another video, which we go into the A to D accuracy on these chargers and the limitations of them. And a tack switch, which has got corroded, look, can you see? Got corrosion on it. These tack switches on these CTEKs often are no good, so we'll check that as well. Alright, so scooting over back to here. the power end of things. Doesn't look good, does it? So let's set to it with the multimeter and see what we can find. Okay, so what have we got? I typically want to take this all out of the case. So the first thing to do is locate the FET, the power switching transistor. We'll zoom in a bit if we can. Will do. So that's a protection diode inside the FET. So the FET is not shorted. Usually you would just get a 0 voltage. We're on forward diode continuity check. Plenty of videos online that show you what that actually does. So the FET is not shorted. It's not to say that the FET is actually working, but it's not shorted. Okay, so the FET seems okay. No direct shorts on the connections of the FET. Now looking around down here, we've got 470 ohm. Presume that's very low resistance. It's reading 1 ohm. It's not got the resolution, but it seems to be okay. We'll take that as read. This is a snubber diode. It's blackened. Has it gone short? So this is the diode which feeds back the stray inductance back into the power circuit. It protects the FET and also somewhat improves the EMC and the efficiency of the power supply. So we've got 0.5 volt one way, which is what you would expect for a normal silicon fast recovery diode. And the other way it's open circuit. So that hasn't gone short, so it's not that. What else can we check at the moment? We've got various transistors around here. I'm going to leave those for the time being because clearly the area of concern is around here somewhere. 4.7k resistors won't have blown, they'll be fine. We'll check those in a moment. We'll switch to resistance. So what about these rectifier diodes? Okay, that way. Okay, that way. Short. Short. Okay, that way. Okay, that way. Short that way. So we've got two shorted diodes, that one and this one. Right, so the first thing is we've got two blown diodes on the bridge rectifier, which is very unusual. All I can say is that these diodes bought from China in the Chinese market are incredibly cheap. If you don't believe me, have a look on lcsc.com, which is the Hong Kong electronics equivalent of radio spares or Farnell in the UK. And yeah, they're like a cent each or something. But you know, you can make things too cheap, can't you? You certainly can. And I don't even know what they are. They're going to be 1000 volt, 1 amp, straightforward, generic rectifier diodes. So I suppose also we ought to check the mains fuse, which is this bit round here. There's the old fuse. Open circuit, okay, so the fuse is gone as well. Now as for this device, there's no signs of trauma, no signs of a stain or an eruption on there. Yeah, and there's no real shorts on there, so it may just be limited to these rectifier diodes have caused a problem, and we've got an incipient problem or an imminent problem happening down here where there's leakage across this board. You notice on the other ones we've checked, the other serious IP65 battery chargers, they lacquer this board, and it's probably a good idea if you take yours apart is to put some clear waterproof lacquer, obviously non-conductive lacquer, but any sort of pure polyurethane lacquer will prevent the moisture condensing on it and will give you a fighting chance. It won't give you full protection, but it will make things a lot better. So we've got to clean all this off, do something about that gap, maybe just take the solder off these pads and trim the copper off and then resolder them so we have a better gap there, and then clean off the whatever it is that's coated it. But it might be a very simple repair of just these rectifier diodes. Let me find some and I'll come back. Right, I've got these rectifiers which we can use very tried and tested. The positive leads at that end, so the positive lead has got to go down to, well, that's annoying. That's the positive there, isn't it? We've got AC, AC, negative, positive. So that's AC and that's AC, so they're completely in the wrong bloody places. How typical is that, really, honestly? There's enough room, actually. I checked it. I trimmed those legs off and put some Kapton tape to insulate it. And if I put it down that way, we need a AC short lead, an AC short lead, so that's fine. Let's put it around that way. AC, AC, and negative. Positive's got to go in the middle, so it doesn't really matter which way around it goes. Okay, I'm with you now. So I've got to bring this leg over to there and solder it on that point there, but otherwise it can go on, can't it? So do we need any sleeving? What do you think? I think if it goes there, make it flat on the board. I've checked there's enough room for this to fit between the board and the case, because this is face down in the case, facing the control panel. I wonder whether we need to put some sleeving on. Do you know what I think I will? I think I will. Some short bits of sleeving. We've got the old Putfer sleeving, PTFE, polytetrafluoroethylene sleeving. It's pretty heat-proof stuff. Although you don't want to burn it with a blow lamp or machine it when you're smoking, because it can be extremely poisonous because it makes phosgene gas. I had a colleague who was taken to hospital after smoking while machining a PTFE insulation bush for a radar set. It's like a 80 kV insulation bush out of PTFE, and he was machining it away, and he had cigarettes. He was smoking on his lathe back in the day, and yeah, he was having a nice fag. A bit of PTFE got on the end of his fag, and he puffed it in, and he was working away, and then suddenly started his eyes rolling in his head, and he was all foaming at the mouth, and it was PTFE poisoning. Putfer poisoning. Right, okay, so the positive one is there. It doesn't matter which way we put this around, it makes no difference whatsoever. Let's have some sleeving on that one as well. We won't need to sleeve that one because it's the same potential as the wire, so let's just bend those down. Yeah, so it's weird stuff. Okay. Okie dokie. Yeah, this Kapton tape is very good. It's very heat proof. Look, 400 degrees, no problem at all. And they used to use it in aircraft wiring looms in the hold, you know, to basically protect the looms, insulate them. And they thought if there was a fire, it would help to protect the wiring for longer than if you'd used a, say, give the aircraft more chance of survival. Say if you'd used ordinary PVC sleeving on the cables. But they had a few aircraft came down after a fire in the cabin, in the hold, fire in the hold, and yeah, it was. They couldn't work out what it was, and then one day one managed to land, and they found that the wiring loom had burnt out about halfway down. And when there was a spark across some conductors where it was chafing, if there was an arc, it would catch this in the arc and make it into a plasma. And once the plasma formed, it would go down like a giant firework. So they had to strip out all, I think it was 727s. They had to strip out all the wiring looms in the aircraft and change them over. So this one needs to go down to there, and that one needs to go to there, doesn't it? So a bit of sleeving on that one. This is why I should have the right diodes in stock, then I could just change them rather than modify. But these are good rectifiers, these little rectifiers, I've used them a lot. Okay, So this one just needs to go down onto there, like that. Down to the negative line. Just check. Yeah, that's negative. And this one needs to be bent over to the positive line. Well, they have sensibly stitched the wires through to the other side, which is nice. Now, like that. Go on. Nice thing about soldering with PTFE is you can leave the iron on for as long as you like. Right. Okay. All right. So there we have it. So I think the best bet for this, the plan, would be to give this a bit of a clean, wouldn't it? I'm going to hold this over my bin whilst I'll do this. Ah, smoke and alcohol. Find me alcohol, that is. Right, so I'm going to give this a bit of a clean. Soak in for a minute and then brush it over the bin. Clean the whole thing a good clean. Okay, let's just deal with this problem with the lead spacing on this FET not being wide enough. Let's just soak off the solder from the joint. Also, I think some of the lovely unleaded needs to go on, or sorry, lovely leaded needs to go on to make the thing more workable actually. So it's really between those two connections, the ones we're looking at. And that one actually. So okay, so you can see there's the actual what we have left. So just going to remove a little bit of copper around the outside if I can get in there. Alright, so we made those significantly narrower so there's less likely to be any tracking across those joints. Right, so that's opened up those spaces. We've at least doubled the space between the tracks, which will give a big improvement. And I think before I put it all back together again, I am going to lacquer those. A clean over the bin. So we've got some more space between the legs on that power transistor to stop the tracking, and any moisture that gets on there is less likely to cause a problem. So I think we're about ready to power it up. I think the other thing we need to do is just check this switch. I found on these, if the moisture gets into them, the switch often fails to work. Okay, that switch is okay, so we can leave that. No need to do anything with that. So I think we can try it out, can't we? We can see whether we can get some life from this thing. So let's zoom out slightly. And we'll put some of a imagine his mains on and see. We'll turn the variac right down. Put the power meter on, see what's happening in terms of power going into it. At the moment I'm just going to stick in 20 volts or something like that and see whether we've got the right voltage being developed. I haven't done something stupid with the voltage, so put this on voltage. DC volts, there we have it. Plug her in. Okay, so it's live now. Let's just see whether we've got the right polarity of voltage being generated across the main smoothing capacitor, which is this one here. .3 volts, that seems a bit low. In fact, that seems very low. I know what's wrong. The fuse itself has blown. So, interestingly enough, I noticed, I've done a video on fuses which I haven't loaded yet, and I've noticed that these fuses don't go fully open circuit. They kind of get carbonized inside and they're still leaking. So even though the fuse is blown, some power is still coming through the fuse, which is quite interesting, or not, depending whether you find these sort of things interesting or not. It's really up to you. Right, let's get that fuse out, shall we? Put some of the lovely leaded solder on. You noticed we've got 250 volts AC coming in there. You notice they have routed out a slot in the board to stop the fuse tracking. There we are. Get the where's the mother sucker? She's in the cupboard. Yeah, fuses are interested and they don't behave like you would expect. They behave in a very strange fashion. And a fuse isn't a fuse isn't a fuse. What was that fuse supposed to be? 2 amp fuse. Kingdom for a fuse. Somebody, anyone? Fucking fuse, it's gone. Right, here we are. Fuses. 3.15, 5, 2.5. We want a 2 amp. 2 amps. 2 Chinese amps. Will the Chinese fuse blow before your house burns down? Place your bets right here. Right. It's a different body. It's one of the little square ones, look, but it does the same thing. It'll fit down the same holes. There we are. Same pitch as well. Look at that. Marvellous. unusual fault, as I say. Rectifier diodes blown like that doesn't happen very often at all, but these diodes are so cheap, so cheap, and such rubbish. Who knows why they went? Clearly not a happy diode. Alright, so let's try again. Let's turn it down a bit, put the power in. There we are. So we're pumping like 30 volts probably, just make sure we've got the right potential across our capacitor. So we are on DC volts, he says. There you go, DC volts. And we got 56 volts DC without any real grief happening. So, oh look, having said that, even on 56 volts DC, can you see that? Can you see that? It's running already. Not very happily, I have to say. So let's wind it up to the full 250. Let's turn it off first. Put our 220, 240 volts in. Turn it on, and bang. Oh, it's working. Alright, so that's... don't think it will respond until a battery is connected. But that's repaired now. So yeah, just a simple bridge rectifier and a little bit of moisture. So I'm going to take this down the shed and mask up this switch here and then spray some lacquer on to protect it in the future. And that pretty much concludes the repair. So simple fault. If you've got one, check your bridge rectifiers, check those components I showed you, and you know, some of them are really badly blown up and damaged, and others are like this one, a simple repair. So yeah, if you like that, then if you're not subscribed, hit the titty button down the corner and subscribe. If you are subscribed, well, thank you very much. And that concludes the repair.